Factoring polynomials. Imagine that we are trying to find the area of a lawn so that we can determine how much grass seed to purchase. The lawn is the green portion in figure 1. The area of the entire region can be found using the formula for the area of a rectangle. A equals length times width. The areas of the portions that do not require grass seed need to be subtracted from the area of the entire region. The two square regions each have an area of A equals S squared equals 4 squared equals 16 units squared. The other rectangular region has one side of length, 10x minus 8, and one side of length, 4, giving an area of A equals length times width equals 4 times 10x minus 8 equals 40x minus 32 units squared. So the region that must be subtracted has an area of 2 times 16 plus 40x minus 32 equals 40x units squared. The area of the region that requires grass seed is found by subtracting 60x squared minus 40x units squared. This area can also be expressed in factored form as 20x multiplied by 3x minus 2 units squared. We can confirm that this is an equivalent expression by multiplying. Many polynomial expressions can be written in simpler forms by factoring. In this section, we will look at a variety of methods that can be used to factor polynomial expressions. Factoring the greatest common factor of a polynomial. When we study fractions, we learn that the greatest common factor of two numbers is the largest number that divides evenly into both numbers. For instance, 4 is the GCF of 16 and 20 because it is the largest number that divides evenly into both 16 and 20. The GCF of polynomials works the same way. 4x is the GCF of 16x and 20x squared because it is the largest polynomial that divides evenly into both 16x and 20x squared. When factoring a polynomial expression, our first step should be to check for a GCF. Look for the greatest common factor of the coefficients, and then look for the greatest common factor of the variables. Greatest common factor. The greatest common factor, GCF of polynomials, is the largest polynomial that divides evenly into the polynomials. Example 1, factoring the greatest common factor. Factor 6x cubed, y cubed, plus 40x squared, y squared, plus 21xy. Solution. Find the GCF of the expression. The GCF of 6, 45, and 21 is 3. The GCF of x cubed and x squared and x is x. Note that the GCF of a set of expressions in the form x to the nth power will always be the exponent of the lowest degree. And the GCF of y cubed, y squared, and y is y. Combine these to find the GCF of the polynomial 3xy. Next, determine what the GCF needs to be multiplied by to obtain each term of the polynomial. We find that 3xy multiplied by 2x squared, y squared equals 6x cubed, y cubed, 3xy multiplied by 15xy, and it equals 45x squared, y squared, and 3xy multiplied by 7 equals 21xy. Finally, write the factored expression as the product of the GCF and the sum of the terms we needed to multiply by. 3xy multiplied by 2x squared multiplied by y squared plus 15xy plus 7. Analysis. After factoring, we can check our work by multiplying. Use the distributive property to confirm that 3xy multiplied by 2x squared, y squared plus 15xy plus 7 equals 6x cubed, y cubed plus 45x squared, y squared plus 21xy. Factoring a trinomial with leading coefficient 1. Although we should always begin by looking for a GCF, pulling out the GCF is not the only way that polynomial expressions can be factored. The polynomial x squared plus 5x plus 6 has a GCF of 1, but it can be written as a product of the factors x plus 2 and x plus 3. Trinomials of the form x squared plus bx plus c can be factored by finding two numbers with the product of c and a sum of b. The trinomial x squared plus 10x plus 16, for example, can be factored using the numbers 2 and 8 because the product of those numbers is 16 and their sum is 10. The trinomial can be rewritten as a product of x plus 2 and x plus 8. Factoring a trinomial with leading coefficient 1, a trinomial of the form x squared plus bx plus c can be written in factored form as x plus p multiplied by x plus q, where pq equals c and p plus q equals b. Q&A. Can every trinomial be factored as a product of binomials? No. Some polynomials cannot be factored. These polynomials are said to be prime. Example 2. Factoring a trinomial with leading coefficient 1. Factor x squared plus 2x minus 15. Solution. We have a trinomial with leading coefficient 1. B equals 2 and c equals negative 15. We need to find two numbers with a product of negative 15 and a sum of 2. In Table 1, we list factors until we find a pair with the desired sum. Now that we have identified p and q as negative 3 and 5, write the factored form as x minus 3 multiplied by x plus 5. Analysis. We can check our work by multiplying. Use FOIL to confirm that x minus 3 multiplied by x plus 5 equals x squared plus 2x minus 15. Q&A. Does the order of the factors matter? No. Multiplication is commutative, so the order of the factors does not matter. Factoring by grouping. Trinomials with leading coefficients other than 1 are slightly more complicated to factor. For these trinomials, we can factor by grouping by dividing the x term into the sum of two terms, factoring each portion of the expression separately, and then factoring out the GCF of the entire expression. The trinomial 2x squared plus 5x plus 3 can be rewritten as 2x plus 3 multiplied by x plus 1 using this process. We begin by rewriting the original expression as 2x squared plus 2x plus 3x plus 3, and then factor each portion of the expression to obtain 2x multiplied by x plus 1 plus 3 multiplied by x plus 1. We then pull out the GCF of x plus 1 to find the factored expression. Factor by grouping. To factor a trinomial in the form ax squared plus bx plus c by grouping, we find two numbers with the product of ac and a sum of b. We use these numbers to divide the x term into the sum of two terms and factor each portion of the expression separately. Then factor out the GCF of the entire expression. Example 3. Factoring a trinomial by grouping. Factor 5x squared plus 7x minus 6 by grouping. Solution. We have a trinomial with a equals 5, b equals 7, and c equals negative 6. First, determine ac equals negative 30. We need to find two numbers with a product of negative 30 and a sum of 7. In Table 2, we list factors until we find a pair with the desired sum. So, p equals negative 3 and q equals 10. Rewrite the original expression as ax squared plus px plus qx plus c. Factor out the GCF of each part. Factor out the GCF of the expression. Analysis. We can check our work by multiplying. Use FOIL to confirm that 5x minus 3 multiplied by x plus 2 equals 5x squared plus 7x minus 6. Factoring a perfect square trinomial. A perfect square trinomial is a trinomial that can be written as the square of a binomial. Recall that when a binomial is squared, the result is the square of the first term added to twice the product of the two terms in the square of the last term. A squared plus 2ab plus b squared equals a plus b raised to the second power, and a squared minus 2ab plus b squared equals a minus b raised to the second power. We can use this question to factor any perfect square trinomial. Perfect square trinomials. A perfect square trinomial can be written as the square of a binomial. A squared plus 2ab plus b squared equals a plus b to the second power. Factoring a perfect square trinomial. Factor 25x squared plus 20x plus 4. Notice that 25x squared and 4 are perfect squares because 25x squared equals 5x squared and 4 equals 2 squared. Then check to see if the middle term is twice the product of 5x and 2. The middle term is, indeed, twice the product. 2 multiplied by 5x multiplied by 2 equals 20x. Therefore, the trinomial is a perfect square trinomial and can be written as 5x plus 2 squared. Factor 49x squared minus 14x plus 1. Factoring a difference of squares. A difference of squares is a perfect square subtracted from a perfect square. Recall that a difference of squares can be rewritten as factors containing the same terms but opposite signs because the middle terms can cancel each other out when the two factors are multiplied. A squared minus b squared equals a plus b multiplied by a minus b. We can use this equation to factor any differences of squares. Differences of squares. A difference of squares can be rewritten as two factors containing the same terms but opposite signs. A squared minus b squared equals a plus b multiplied by a minus b. Example 5. Factoring a difference of squares. Factor 9x squared minus 25. Solution. Notice that 9x squared and 25 are perfect squares because 9x squared equals 3x squared and 25 equals 5 squared. The polynomial represents a difference of squares and can be rewritten as 3x plus 5 multiplied by 3x minus 5. Q&A. Is there a formula to factor the sum of squares? No. A sum of squares cannot be factored. How to? Given a difference of squares, factor it into binomials. 1. Confirm that the first and last terms are perfect squares. And 2. Write the factored form as a plus b multiplied by a minus b. Factoring the sum and difference of cubes. Now we'll look at two new special products, the sum and difference of cubes. Although the sum of squares cannot be factored, the sum of cubes can be factored into a binomial and a trinomial. A cubed plus b cubed equals a plus b multiplied by a squared minus ab plus b squared. Similarly, the sum of cubes can be factored into a binomial and a trinomial, but with different signs. A cubed minus b cubed equals a minus b multiplied by a squared plus ab plus b squared. We can use the acronym SOAP to remember the signs of the factoring of the signs when factoring the sum or difference of cubes. The first letter of each word relates to the signs same, opposite, always, positive. For example, consider the following example. X cubed minus 2 cubed equals x minus 2 multiplied by x squared plus 2x plus 4. The sign of the first two is the same as the sign between x cubed minus 2 cubed. The sign of the 2x term is opposite, and the sign between x cubed minus 2 cubed and the sign of the last term, 4, is always positive. Sum and difference of cubes. We can factor the sum of two cubes as a cubed plus b cubed equals a plus b multiplied by a squared minus ab plus b squared. We can factor the difference of two cubes as a cubed minus b cubed equals a minus b multiplied by a squared plus ab plus b squared. How to? Given a sum of cubes or difference of cubes, factor it. 1. Confirm that the first and last terms are cubes, a cubed plus b cubed or a cubed minus b cubed. And 2. For a sum of cubes, write the factored form as a plus b multiplied by a squared minus ab plus b squared. For a difference of cubes, write the factored form as a minus b multiplied by a squared plus ab plus b squared. Example 6. Factoring a sum of cubes. Factor x cubed plus 512. Notice that x cubed and 512 are cubes of 8 to the third power equals 512. Rewrite the sum of cubes as x plus 8 multiplied by x cubed minus 8x plus 6, 4. Analysis. After writing the sum of cubes this way, we might think we should check to see if the trinomial portion can be factored further. However, the trinomial portion cannot be factored, so we do not need to check. Example 7. Factoring a difference of cubes. Factor 8x cubed minus 125. Solution. Notice that 8x cubed and 125 are cubes because 8x cubed equals 2x to the third power and 125 equals 5 to the third power. Write the difference of cubes as 2x minus 5 multiplied by 4x squared plus 10x plus 25. Analysis. Just as with the sum of cubes, we will not be able to further factor the trinomial portion. And factoring expressions with fractional or negative exponents. Expressions with fractional or negative exponents can be factored by pulling out a GCF. Look for the variable or exponent that is common to each term of the expression and pull out the variable or exponent raised to the lowest power. These expressions follow the same factoring rules as those with integer exponents. For instance, 2x raised to the 1/4 power plus 5x raised to the 3/4 power can be factored by pulling out x raised to the 1/4 power and being rewritten as x raised to the 1/4 power multiplied by 2 plus 5x raised to the 1/2 power. Example 8. Factoring an expression with fractional or negative exponents. Factor 3x multiplied by x plus 2 raised to the negative 1/3 power plus 4 multiplied by x plus 2 raised to the 2/3 power. Solution. Factor out the term with the lowest value of the exponent. In this case, that would be x plus 2 raised to the negative 1/3 power. Factor out the greatest common factor, then simplify.